I was spending hours every week deciding what to eat. I had to search recipes, check ingredients for allergies, count calories, and then make a shopping list. Athletes, busy parents, and people with dietary restrictions face the same problem. There are too many factors like nutrition, diet type, time, cost, and taste. So people get decision fatigue and often fall back to random or unhealthy options. So I wanted an assistant that could handle all of this automatically. For making this agent, I used a multi-agent system because it matches how humans solve this problem. In real life, a nutritionist focuses on macros, a chef on recipes, and someone else on shopping. MealMaster copies that with separate agents for planning, nutrition, recipes, and shopping. Each agent has a clear job, and they collaborate. This makes system easier to extend is exactly what the practical life assistant agents tech is about, a specialized agents working together on a real daily task. So here is the architecture. The planner agent, which is the brain, it receives the user profile, calorie target, diet type, allergies, and goal. It asks the nutrition agent to compute per meal calorie targets. For each meal type, it calls the recipe agent, which filters recipes by diet, removes allergens, and ranks them using TF-IDF and nutrition scores. Once 7 days of meals are selected, the planner agent sends everything to the shopping list agent to build a categorized, deduplicated shopping list. Finally, the whole plan and user profile are passed to Gemini, which generates a short, natural language explanation of how well the plan fits the user. I built MealMaster in Python. I used pandas and NumPy to handle recipe and nutrition data. Scikit learns TF-IDF and quotient similarity for understanding and ranking recipes, and Matplotlib to visualize calorie targets and weekly plans. The multi-agent logic is implemented as separate Python classes. For LLM reasoning, I integrated Gemini so it can generate explanations of each plan. The project runs as a Kaggle notebook for experimentation and can also run on Vertex AI for a scalable deployment. So this is my VS setup. So let's go through every section. Firstly, we have done some imports to run these codes like JSON, Pickle, NumPy, and other like Vertex AI and Gemini. Then second section is configuration of these both Vertex and Gemini LLM. And section 3 and 4th is about dataset, where in third we have given some breakfast, lunch, and dinner options. And in fourth we have subcategorized into allergies and some carbs and fats, as you can see. Then fifth is about agent classes. There are, since it is multi-agent systems, so we have different agents like nutrition agent and nutrition recipes, shopping lists. Next section is about Vertex and Gemini integration, so that we can get summary form of our output, that is our recipes. Next is about demo executions. As I have already run this code in, so let me show you through terminal. So moving to our next section, when I have run this code, it is successfully imported like every Vertex AI, and I have given 3 profile set for like athlete, teenager, and for busy parent for our demo. And it will show sample day, like for one day it will show what will be recipe followed and what we have to do shopping list on particular day. So our Gradio UI interface is ready. Let's go through. So if we change our calorie target from 2200 to 2000, and if we want to dietary philosophies, let vegetarian or vegan diet, and let's say I have allergy from gluten and I want a healthy diet. So when we will submit this, it will
take some time to generate that plan, around 12 seconds. So let's wait for it. So here it is, our nutrition summary. Like it is given that target hour is 2000 calorie, but we will achieve only 832 calorie per day, which is accurate around 41%. And it is so for sample day, we have dinner grilled tofu with vegetables, and our shopping list are for tofu, vegetables, pantry. And it is by Gemini, it is given that plant successfully meets our 41% of nutrition targets. And if you want, and I have to do more work on this particular agent so that it generate more 7 days week plan, or it should be we have to give more data it so that its accuracy increases to 92 to 100 92 to like most accurate to achieve its target. So thank you everyone. So this is our Gradio UI interface wherein we will, let's say, change our calorie target to 2000. Our dietary philosophy would be vegan, and let's say we have allergies from gluten, and we want a healthy recipes. So when we will submit it, it will take some time, around 10 to 12 seconds, to generate our recipe. So let's wait for it. So here you got our nutrition summary. This is showing actual target is fulfilled around 832 calorie, which is and with accuracy 41%, which has protein around 66 grams and carbs and fats, you can see. So we need to work more in this to make it more accurate to hit target. And it is given only for sample day, like it is only for 1 day, and but I need to work more to get our weekly plans, and then next is monthly. And to make this, we have, it has also Gemini to summarize that plant successfully meets our 41% of nutrition. And for shopping, we have for protein we have to buy tofu 7 portions, veggies, and pantry like salt and pepper. So in short, MealMaster turns hours of manual planning into a few seconds of intelligent automation. Multi-agent coordination handles the hard constraints, and Gemini makes the results understandable. It's an example of how practical life assistant agents can genuinely simplify everyday life. Thanks for watching.